So, good morning. Today I'm going to be talking on the role of Python programmer. I was specialized in AI development. So, in my first course, I'm welcoming you to today's presentation. So, today we're going to be touching these key topics: mutability, iteration and types, dictionaries, booleans, operators and operands, functions. I'll actually showing you guys some codes I've written throughout the course of my study, then total graphics, and also be sharing some dad jokes again. So first of all, the first slide tells us about data types and values. So a value is one of the fundamental things, like a word or a number, that a program manipulates. So what we give to our IDE or our interpreter, our values, we give them these values in form of algorithms or instructions for it to run our codes. So in programming, data type refers to classification of data items. They define the types of values, such as whether it is an integer, a float, a string, or something else, and it determines the operation that can be performed on the value. So variables, operations, and operand. What are variables? In programming, a variable is a name storage location that adds a value. So a variable now is like a name in which we store a certain sentence or statement which we want our code, our Python interpreter to carry out. So we have various types of variables. We have the integer variable, the float variable, the list variable, the string variable, and many more. About operations now. Operands are values or variables that are used in an operation. Operations are actions performed on these operands. And we have the logical operations, the comparison operations, the mathematical operations, the assignment operators. Moving to the next slide, we have examples of operators. We have the mathematical operators having addition, a plus b, subtraction, a minus b, multiplication, a asterisk b, division, is backward slash b. Then the comparison operator is usually when we want to say that a particular item is equal to another item, or a particular variable is equal to another variable, we use a double equal to sign to show equality. Comparison operator now. Then for not equal to, use an exclamation point, then an equal to sign, telling us that a value A is not equal to a value B. The third one is the greater than sign. The greater than sign is another comparison operator. Then we have the less than, we have the greater than equal to, and also the less than equal to. Then assignment operators. Assignment operators, the simple assignment. A is equal to B, that is like a variable now is assigned to this expression. Then we also have A plus equal to B. A plus equal to B is another way of writing A is equal to A plus B. That means giving a variable A and equating another variable A, adding the first or initial variable plus another variable B, which was given in our code. Then the subtraction, same thing, A minus equal to B is also equal to A equals A minus B. Then we have the multiplication assignment, same as this one, but with the multiplication sign. Then we have logical operators. We have AND, where when I go further, you see that if two, like in our comparison using Boolean values, if we have A having a value of true and B having a value of true, our total printout, our run code will tell us that our statement is true. But if just one is true, it will print out false. That's how AND works. Then or, if at least one of our statements is true, it will print out true. But only if both of them are false, that's when it print out false. Then not A. This is just basically simple. Let's say I am here it prints true now, but I am not here, it prints false. If I'm not here, it prints false. Moving on. We have that there are only two Boolean values, basically. There are only two Boolean values. These are true and false. Capitalization is important since true and false are not Boolean. Remember, Python is case sensitive. So having something like true with a small t is just like a text and not a Boolean value. A Boolean value must have capital T and capital F, and it is never enclosed in a quotation mark. If not, it will be considered as a string. So if I print true, it prints out true. I print type true. That is, this type function is telling me the type of data type that is true and is false is. So it's telling me that they are both Boolean values. So checking here now, you see that there's a quotation mark added here, and it prints that the data type is a string, the class is a string. So that's why when writing Boolean expressions, your true and false must have capital T. Then you put quotation marks, they are no more Boolean values, and if you use small letters, they are now considered as text, just normal text. So, checking our understanding, which of these is a Boolean expression? True is a Boolean expression having capital T. This is comparison. So, is this equal to this? The answer is no. So, it will be false. It's a Boolean expression. Then also, this one is just an expression. Let's say, given to a variable A. So, it's not Boolean because there's no comparison occurring at any side. So this 7 is equal to 7. This is a comparison operation. So it prints out true if we write it now IDE. So X or Y yields true. This is the logical operation now. X or Y yields true if either X or Y is true. That means if either one of them is true, the answer becomes true. Only if both operands are false does all statement or all operator yield false. Not X yield false if X is true and vice versa. So if X is 2 now and the ask not X is equal to 3, it prints out true because X is not 3, X is 2. So look at the following examples. Let's see if we can predict the output. So they told us that X equals true, Y equals false. Print X or Y. You can see that X is true, that means one of them is true, and the other is false. But it's the operation here, the operator here is false, so it prints true, because at least one of them is true. Then print X and Y. So X is true, Y is true. So for and to be for and to be true, the both of them have to be true, otherwise it produces false. So since only one is true, it produces false. And print not X. Since X is true here, so not X should be false. So making progress, normally, this is when we tell a dad joke about Booleans, but it will not be considered as a joke because the problem with Boolean jokes is that we programmers always want to know if it's actually true or false. So moving on. In order to write useful programs, we almost always need the ability to check conditions and change the behavior of programs accordingly. Selection statements sometimes also referred to as conditional statements give us this ability. The simplest form of selection is the if statement. This is sometimes referred to as binary selection since there are two possible paths of execution. So let's say we have a variable X, assign an integer 15 now. If X modulus 2 is equal to 0, we have to print that x is even. That means we're using if and else if function here. If x, which is 2, that means the remainder of x of 15 divided by 2, if it's 0, we're going to print x is even. Otherwise, we print x is odd. So obviously 15 divided by 2 is 7 remainder 1. So obviously it's going to print x is odd because the remainder is not equal to 0. So that's why the Python interpreter printed 15 is odd there. Then checking our understanding again, how many lines of code can appear in the indented code block below if and else line, if the else line is a conditional. So if you are using your if statement, you must always write one code or more under that if or else statement. So that's why it should be one or more. It can't be just one because you can give different conditions to after your if and else statement. It can't be 0 or more because under your if or else there must be a particular instruction you are assigning that that function to. Then one or more and each must contain the same number. That's 4. Then what does the following code print out? We said if 4 plus 5 is equal to 10, comparison now, print true, else print false. So 4 plus 5 is equal to 9, but it's not equal to 10. So the Python interpreter tends to print false because those two sides are not equal. So writing simple codes, we said create a variable b and assign it to the value 15. Then write codes to see if b is greater than that of a. If it is, a's value should be multiplied by 2. If the value of b is less than that of, is less than or equal to a, nothing should happen. So finally, create a variable c and assign it to the value of the sum of a and b. So this is the written code. First of all, they said we should assign it. They gave us a value a. They then said we should look for, we should make a variable b and assign it to the value 15. Then they said we should write a code to see if b is greater than a. So this is the code now. If b is greater than a, we should print b is greater. Then print, then they now said that if it is, if it is, a's value, a's value should be multiplied by 2. So this is the if statement now telling us that if b now is greater than a, we should print this value is greater. Then if that is true now, we should print we should multiply a by 2. Before we can multiply a by 2, we have to convert it to an integer obviously. Then else, if the value of b is less than or equal to a, if the value of else we should print else we should print nothing. If the value of b is less than or equal to a, we should print nothing. And finally, we should assign a variable c as the sum of a and b. So what this means is that when we check if b was greater than a, 15 is less than 20. So that's why this statement did not print out. But else, if a is now greater than b, that means if is like the opposite of the else statement. So since a now is greater than b, we're going to now print nothing should happen because that was what was told to us in our instruction. Then they now said I should print the sum of a and b to a variable c, and that's what we need there. So here's a bad joke for us. A programmer is heading out to the grocery store and their roommate tells them to get a gallon of milk. If they have eggs, get a dozen. So the programmer returned with 13 gallons of milk. Miscommunication, basically. So let's run some codes I prepared during the course of this program. So I'll take you to the PyCharm IDE where you can have some mathematical codes from turtles, talks, and many more codes. There's also a game of it to try out. Yeah. So first of all, we'll be starting with our Turtle graphics code. When we drew a hexagon, first of all, we imported Turtle, then we named the screen to Turtle screen, then we gave the screen a background picture gold, then named the Turtle. We named the Turtle, then my Turtle speed. Basically, this is like codes using to perform a particular function. So if we run the code, you see that something is drawn. The reason why they have different colors, the size of the hexagon has different colors, because we gave each side a color. You can see the first side gets gray, second side gets green, third side gets blue, and so on. And the background picture was gold. That's why it's run like that. That's why I run like that. So moving on, we have the random, and length function. Okay, so RB here is giving us a list of items. Not a list, like a sequence of names. We have Marvel, Frances, Tudor, Isaac, Emmanuel, Jedediah, Divine. So numchar is equal to length of RB. This means that we want to find length of the characters in the RB, the variable RB. So when we print numchars, this code will print the total number of characters there. It prints the total number of characters as 61. That means if you count everything here, including the space, you get 61, as shown somewhere here. Then import, we're playing with the random function now. So let's assign a variable boy and give an assignment random function basically. So when we print boy, a random number occurs between a range of 0 to 1. And each time you run the code, the random function changes. Random number changes each time you run the code in the output window. It's always changes. Then print 1/2 as a percentage. That means half times 100. That's a mathematical something. Then the number guessing game. How it works. The program generates a random number where you are to guess between 1 to 100. The user is prompted to enter their guess. If the guess is too low or too high, the Python gives feedback. The program gives feedback. If the user continues guessing until they correctly guess the number. Okay, the program tracks how many attempts it takes to guess the correct number. So we're still using the random function here. So when we import the random function, we print a welcome message, like welcome to the number guessing game. I am thinking of a number between 1 and 100. So the Python interpreter, or basically the background worker, is one to think of the number where you, the programmer or the person playing the game, guesses. So we're to guess a number between 1 to 100, and if we get the number, if we don't get the number once, the game allows us to keep trying until we get the number, but it gives us feedback as to how close we are. So say we guess a number of 55, it tells us that the number is too high, we should try again. Guessing a number of 45, it tells us too high, so moving to 35, it tells us too high again. Moving to 20, it tells us that congratulations, you have guessed the numbers in 4 attempts. So this is a game that it gives you a space to write your guess, the number that you guess it to have chosen. Then it tends to give you the chance to keep writing your guesses, but it gives you feedback as to how close you are to get your answer. And those feedbacks will help you to like will help you to get close to your answer. So that's like a gaming a game I built yesterday night. So we have the even, odd, and prime number function. So I use the even and odd. One my partner Emmanuel gives the prime number calculator. So this code helps to determine a number that's a prime number, a number that's even, and a number that's odd. Also a number that's a multiple of 3. So if I run the code, it tells me to enter a number, and I enter a number of, let me say, 63, and I run it. It tells me that the number is a prime number. Of course, it's not a prime number. It is an odd number. Of course, it's an odd number, and it is a multiple of 3. You know that. Let's go with something little. Say 12. For a number 12, when we enter it, it tells us that 12 is not a prime number, obviously. It's an even number, and it's also a multiple of 3. So this program is written with caution and care as to how far we have understood that hard code intends to terminate your code. It prints it out, but not the way you want it, but it just prints it out normally. So we use mathematical operations to run this code so that it will be like accurate and not have errors. Then a modified calendar. You import a calendar library or something like that. Then you name a variable here, impute your integer, like to convert the string to a number. You impute your year, enter your month, enter the day, like it creates a calendar for you. So if I run the code and I enter the year 2025, and I enter the month February, and I enter the day, today is 21st, then it's to print out a calendar for us. Let's print out the calendar for us, carrying the days of the week and telling us that it's February 2025. That's a calendar program. And also a simple weight converter, although it's can be better than this, but if you want to convert from kilogram to gram and from gram to kilogram, this program can help you carry out such codes. So let me go back to my slides. I'm sure you learned something. So moving on, let's dive into comments in Python. Someone wants to write comments. Like when we write comments, this is like explaining our codes to our audience. So if we write a complex code now and our audience tends to like be lost, these comments will help to redirect them to as to how the code functions or how the line of code is meant to work. So we use the hash symbol, sometimes they call it sharp symbol to create comment, because the Python interpreter tends to like ignore everything that comes after that symbol. So hard coding is basically like assigning a variable a number. Like mathematically now, we assign a variable A to have a number 15, assign a variable B to have a number 10, and we just say C, the average is equal to 15. Let's say 20, A is 20, B is 10, then the average is 15. Rather than writing actual code to like calculate that average, we just gave another variable the answer to print out for us. That's hard coding. Your Python interpreter will print it, but you're not giving it something to look to like I just had coding basically because some people would, sometimes your answer might be wrong. The Python interpreter will just like print it for you without solving it. So that's an effect of hard coding. Then the input function. The input function is like a function in Python that allows a user, a programmer, or a student to like type in a particular, when the code is run, he types a number or phrase depending on what he has to type in. If he starts to type in an integer and he puts a string, an error message occurs. That's for input function. Then this is like a sequence of items that are enclosed in a square bracket. They can contain numbers, they can contain strings, they can contain text, and so on. Why a tuple? A tuple is similar to string. Tuples are similar to string, but they are enclosed in parentheses. It can contain numbers, it can contain items, just like this. Then assert functions are like test function. They can help you to check your code from the start if your code is going to be correct. If your code, let's say you have 5 equal to, that's comparison operators now. 5 equal to 5. It doesn't, when you put assert, import assert now, and 5 equal to 5, it tends not to print anything because assert is like checking if your code is going to be accurate, like testing your code before you run it. So if it is true, like if it is going to be correct, it doesn't print anything. But if it's false, or it's going to print something like, let's say 4 equal to 5, obviously that's false. It prints an error statement in your output window. So looking at this now, string 1, we have to like find the total, just like an example I was rendered like this before. You have to find the length of numbers, of the length of characters inside this string. So num length string 1, that's the string 1 is the variable. So the nums is like the length of characters in string 1. So when you print the numbers, you see that it gets 90 there. So everything here, including the space, is counted and equals to 90. So now I'll be explaining some screenshots I took over the course of my study. What is printed when the following statement executes? So remember that Python follows sequence. Like if you have, in this case now, let me zoom in. In this case, you have x equals x minus 3. Then x equals x plus 3. So it calculates line by line until you get to the last one. So here we have x equals 12. Comes here, x equals 12 minus 3, which gives us 9. 9 plus 5, which gives us 14. And x equals 14 plus 1, gives us 15. So Python follows sequence. It doesn't just print out this first x. It follows the sequence. It calculates everything before printing out the x, because the x is like the last line of code after all those expressions there. Then, when the Python interpreter interprets source codes, it runs the instruction according to a strict set of rules that do not allow for ambiguity. So basically, the Python interpreter checks for errors in your code before it runs code. If it finds error, it prints out an error message. But that's to say that it runs the instruction or the algorithm which you put inside the IDE based on certain principles, like the syntactic rules, the semantic rules, and the runtime rules. That is, if you meet all those rules, your code runs smoothly and not with errors. Fill in the blank. Every expression has a value which has a type, saying that you have a variable a equal to an expression. That expression has a value like sequence of numbers, sequence of letters, and a type, integer, float, string. understanding. Which of the following is a syntax error? Forgetting the right parentheses. I've said this numerous number of times. How can you tell that the code will change an item in a list rather than just look up its value? This is the answer. The sequence location, like written on the left side, is an assignment statement. So if you want to change a code from, like you have a list of codes, now you want to change a code, you tend to put the position of that code and give and assign a new item so that to replace that code where you print it in, that list where you print it again. Then dictionaries in Python. A dictionary is a mutable data type that stores markings of unique keys to a value. Just those values now, they're like, let me say, words inside a given variable. So it's an essential data structure in Python that you see frequently when you begin to write advanced codes. So creating a dictionary. You create a dictionary using this constructor or the curly bracket syntax. So my dictionary name equals John. So this is a key in dictionary, and this is like the value attached to the key. The key is like something that, like let me say it's like a variable now outside because of this equal sign. Normally this is a variable, but since it's in the dictionary, we assign name to be a key and this to be a value carried by the key name. Then key value pair, a dictionary consists of key value pairs where each key is unique and marked to a specific value. Like I explained, this is a key and this is a value. I would like to also touch iterations, its types, for loops, while loops, mutability in Python. So iteration, like Jemima said in her presentation on JavaScript, is like repetition. You use for loops, while loops, and nested loops. Iterate over lists, over sequence of characters, over sequence of integers, basically. So the for loop executes over a range of numbers, while the while loop executes due to a condition being true. Or if a condition is true, the program continues to execute. But when it meets false, the program automatically stops. Then mutability in Python. Strings are not mutable, but lists are mutable. Mutable in the sense that you can change a particular item in the list, unlike the string where it's just an item on its own. Mutability is like changing a particular item inside a list. So to wrap up today's presentation, I'm going to be having two dad jokes here. Why do programmers prefer Python? Because it's excellent. And also, why do programmers love Java? You know about that Java game in our small phone. It's because it lacks fun. Thank you. See you next time. Bye, let's do it. So, do we have any questions? Yes, the variable is like, come on, the variable is like a package where you can store your expressions. Like you have A equals B. Like a variable is like what you assign expressions or operations to. Like, you understand what I'm saying? Use that one. Any other question?
The comments that you're talking of, you write them on your Python.
Yeah, you write them on your Python, but after your code, that hash, after the line of code, so that the things you write after the hash, the Python interpreter is going to like ignore them, but run your code. That's like explaining what you are writing.
Okay, so to write comments, you just put hash first.
Yeah, write the comment.
It's Python compiled.
Huh? The Python is like, yeah, it's compiled because it packs all this thing, all the code you run this in a particular place in the output window. All the outputs are compiled. So I think it's compiled.
How does Python manage memory? How does Python managing. How is memory managed in Python?
Memory managed with Python.
Yes.
Well, in like the idea is PyCharm. The Python, the codes now, they are processed and run in a particular IDE. So when you write the code, when you want to let me show you.
Yes, please do.
So when you want to write a code, like a new lab, basically, you create a new this thing. You save it before you start, basically. There's a save feature in your IDE. So you save Python codes there. That's the answer to the question.
The memory.
In memory.
The memory of the codes.
Give me examples of some things you use Python to develop.
Well, you can use Python in hospitals for checking blood pressure, basically. You can use Python in supermarkets, like vending machines. You can use Python codes in clouds too. You can use Python codes to develop in astronomy, basically almost every field. You can use Python in the oil sector. You can use Python
In the
codes.
blood pressure, how does it Python
Okay.
work? Sorry, how does
No,
Python
no,
work?
when you are creating all this thing, like all this artificial intelligence now, inside the machine that checks the blood pressure, they use codes too.
Okay, so what edge?
Jesus Christ.
Sorry, last question. What edge does Python have over JavaScript?
Huh?
What edge does Python have over JavaScript?
Well, I haven't really studied JavaScript, but I heard that JavaScript came into existence way before Python. So I think Python is more understandable to young programmers coming up than JavaScript. That's
Like you.
what I think. Because studying Python is interesting and
Yes.
very interesting. Because you can easily write your codes and understand them. Yeah.
How does Python work with API?
With
API.
API. Just like we said, storage. Sorry. Like communicating with, like me now communicating with my this thing and with like collab now. When I work with him on collab, we're communicating with each other, sharing ideas. So that's how Python works. Am I free to go? Yes, so thank you.
Sorry, last question. Sorry, last question. What is the difference between generator and iterator?
An iterator is like a repetitor. Why a generator is like to bring something new.
God, you have not been recording this boy.
An iterator repeats something, or generator. No.
Alright, no problem.
Thank you all for understanding.